Hey guys, have you ever wondered what's the difference between an array and a list? Well, today in this video, we'll be discussing the key differences between an array and a list, specifically a Numpy array, and why would we want to use it more within machine learning language rather than a regular list. Before we begin, we will be using Jupyter Notebook, so if you haven't yet installed it on your computer, please check out this video here so that you can install it yourself. And without any further ado, let's get to it, guys. Alright guys, for the fun of it, we're going to keep score of which method is best used in which scenario. So we're going to have Numpy over here and list over here. And let's begin. Alright, so the first thing we see is that before we even are able to use Numpy, we first have to import it into Python. Now, if you don't have the Numpy library already installed on your computer, you will need to run the command pip install numpy. It will look like this. And then once you run it, it will install itself. Since I already installed the Anaconda distribution from the previous video, I already have it installed, but if you didn't, it will install regularly for you. And with the built-in list, as the name states, it's a built-in list within Python, so you don't have to install it and it takes no space. So we'll give that scenario a win for the regular list. Now moving forward, let's take a look at the second difference between a list and a Numpy array. Alright, we're going to check out the data types. Now, within a list, you can input any type of data. So that includes a string, an integer, a boolean, a float, within a list. But within a Numpy array, you can put in only one data type at a time. So if you put in a string and an int and a boolean, they would all convert to a string, but within a list, they would all stay as their initial data types. Now, with a list, since we do not convert the data types to a single data type, that means the list size would be bigger to contain all these different data types within one vector, within one list. With a Numpy array, since all the data types are one data type, such as string or integer or float, they all are minimized and compressed into one array, which reduces the size and reduces the amount of space needed to contain that array. So it allows you to quicker run operations on it, or allows you to have more space freed up within your program. So that is a benefit in a way for array, because it allows for it allows for more space. But like I said again, list allows for different or flexibility in the amount of data types that you have if you wanted to use that for a specific situation. So they both are pros and cons in this situation. It just depends on the situation that you have at hand. So let's go ahead and take a look at examples for both. So let's start with a list. So right here, we can see that we have a list with three different data types. One's a string, one's a integer, and one's a boolean. Okay, and now we wanted to see what is the data type for the index of 1 within this list, which we think is an integer, as it is a 1. And as we can see here, we print it out here, and then we see that it is in fact still an integer. So like we said before, lists allow you to keep the data type that you entered when creating the list. But let's go ahead and check with a NumPy array and see what happens. Oh, I gotta run NumPy. I think I did that. As you can see, NumPy converted it over to a string. So now all of the elements within the NumPy array are now strings instead of maintaining their same data types. So as you can see, we print the index 1 here, and then we saw that it is converted over to a string instead of its original data types. So let's give 1 and 1 to both list and NumPy's array, because list contains flexibility of the data types that you can contain within one list. But because of that, the size of the list is bigger. So we will give that to a NumPy array because it allows for smaller. It allows to convert that list object into a smaller size, which then also allows us to perform arithmetic operations, as we will see in broadcasting. So 1 and 1 for list and NumPy. Okay. Now let's move over to broadcasting. What exactly is broadcasting, you may say? Well, broadcasting is a way for NumPy to allow for element-wise operations on different shapes of arrays. So for example, if we wanted to multiply as we see here, let's take a look at a list first. If we want to do 2 times 3, 4 times 3, and 6 times 3, we want the answer to all of these. In a list, if we try to do this, let's see what happens. We get 2, 4, 6, 2, 4, 6, 2, 4, 6. It would just duplicate the array times the amount. But we actually wanted it to perform arithmetic operation, in this case multiplication, onto each element on the list. But if we did this within a NumPy array, we would actually get 6, 12, and 18. So within a list, we can't really do broadcasting like this. So we would have to create a for loop, which is big O time complexity, big O of n time complexity. Rather, with a NumPy array, you get a big O of 1 time complexity. So given this, we'll give a point to NumPy arrays because they allow for quicker arithmetic operations on arrays and rather than lists. Next, we move on to size flexibility. Okay, and what do we mean by size flexibility? Let's say we already have a list right here, which is 2, 4, 6, but we wanted to add 2 more elements onto the list, such as 8, 10, and we named the list extended. So we wanted it to be 2, 4, 6, 8, 10, each containing its own element, of course, each value containing its own element. So the simplest thing we can possibly think of, right, is to just add a list plus extend to give us our new array of a list. And then let's see what we get here. We get 2, 4, 6, 8, 10. This is great. We're able to increase the length of our list while also adding onto new values at the same time. Now let's see if we can perform the same thing with a NumPy array. So we already have our NumPy array. We created a NumPy array 2, 4, 6, and then we created another NumPy array 8 and 10. So we're going to add NumPy array plus equal to extend. This is equivalent to the same thing as we see here. You can switch and swap this type of syntax with each other and they give you the same answer. So we will then print NumPy array. Oops, and we get an error. it says value error, operands could not be broadcast together with shape 3, 2, 3. So with a Numpy array, we cannot exactly add two arrays to each other and get a new size of array. What we'd have to do first is we would have to call, as we see here, the np.size function for NumPy. And if you're not familiar with what any function do, or in general, you can do in Jupyter Notebook, you can do np.resize ? And then if you run this, it will show you what the function does exactly. So for np.resize, it takes a value and a new shape value parameter. All right. So what is A? A is array-like, array to be resized, and we have new shape, which is an int or tuple of int, shape of resized array. So what it's saying is that the first value is it's going to take our NP array that we want to resize, and the size we want to resize it to. And so in this case, we want to add 2 to our array because it is size 246. So we want to make it 5 to add 2 more. So it's 3 plus 2 equals 5, which is what we get here. Then, once we have resized our array, we can then add well, before we even do that, it's gonna show us, let's go ahead and run this. It's gonna show us what it did. What it did was it takes the first two values and then it adds it at the end so that it can make space, or the new space that it created is then equal to the first two elements of the current array. And then of course you can imagine if you added a 6 onto this, the 246 will be 246, so of size 6. So then we continue on to add the extended part that we wanted to add. So we did slicing. So we take the first 3, which is 0, 1, and 2, and 3. 3 is included. So we do 3, 4. All right. So we're gonna grab this 2, and then we're gonna change the values to what is in extend, and then we get 2, 4, 6, 8, 10. So that's how that worked. You can see a lot more complicated than just doing a list plus extend. So we would definitely give this feature to a regular list because it allows for much quicker operation when you want to add two types of lists together. Now let's move on to vectorized operations. Now what is vectorized operations, you may ask? Well, let's say we had a list of 2, 4, 6, 8, 10, as we see here, but we wanted to filter the list to only elements with certain values. For example, we wanted a list that had values of 4 or greater, as we see here. So we have NP array is greater than 4. So we want to somehow get everything that's 4 or greater. Well, in this case, it's greater than 4, so we'll only get 6, 8, and 10. Let's see if we can do this. We get 6, 8, and 10. Okay? So this is what vectorized operation is. It's just performing operations on an array directly. Okay? Now let's say we want to perform this on a list. Let's see how this is done. Let's see what we get. We get an error. Greater than sign not supported between instances of list and int. So within a list, you can't perform query operations like we did as simply with a list. We would once again have to create a for loop, which then makes it a O of n time complexity operation, and with Numpy array that gives you a big O of 1 type complexity, which is of course significantly different. So if you'd want to do this, like I said, I made an example using a list comprehension where you would have to use a for loop, which returns 6, 8, and 10 of type complexity. So we'll give a point here to, of course, Numpy arrays because of its greater flexibility, time complexity. And with that, guys, let's tally up the score. Voila! As you can see, it's a tie between a list and a Numpy array. So the truth here, guys, is that given the situation, you could use either a list or a Numpy array. It just depends on exactly what you're looking for within your specific situation. Within machine learning, we tend to do mathematic operations on large data sets at a single time. So for example, if we have like a class and we want to find the grade point average of all students, we'd want to use a Numpy array as it allows us to do broadcasting operations as we saw earlier in the video. But if we need a list with different data types, we may want to use a list. So guys, it's really up to you and the situation that you're in at that exact moment. So yeah, guys, if you have any questions about this video, please leave it in the comment section. If you like this video, please give it a thumbs up. And until next time, guys, I will see you then.